Okay, so we're talking about applications of geometry and trig. So as I said, we're going to first look at angles of elevation and angles of depression. So they're going to use this wording and they're actually going to help make you set up the scenarios. So you're probably going to have to do a little bit of drawing up the diagrams yourself. Then once you've got the diagram, it's quite easy to go on with it because you're then using one of your trig rules or your measurement rules or whatever. So with the angle of elevation, what we've got to remember is that it's always measured from this horizontal. So this is the horizontal line. So that means there. So if you're always going to measure angles of elevation or depression from that horizontal line. So if the angle of depression is there, there's the horizontal. So you go from the object you're talking about and you go straight out as a horizontal line. Okay, so then when they measure the angle, they're going up from that, up till you get the line that's joining the two objects together. Okay, so down here you can see the line joining the two objects together. The angle of depression is going from that horizontal line down to that. Okay, so when you got to be careful with this person over here, common question, they'll have their own height, and if you have a look you could probably see that you can set up a right angle triangle and say that was a distance there. So if you were talking about what's the height of that balloon would be x plus the person's height. Don't forget to remember that. They'll tell you what the little height difference is, but that's where you've got to make sure you're aware of that. With this angle of depression is the way most people make a mistake, and it's really annoying. So if you say you've got a little cliff top, you've got your person on your cliff top, this is a really common one with the boat or whatever. So they say that the person's looking down at the boat. The angle of depression is from the horizontal, so it's in there. So when they tell you the angle of depression, it is that angle there. Okay, do not use the one in the cliff there. That is not, and you're going to stuff it up if you do. So the angle of elevation and depression always measured from that horizontal line. Now, the angle of depression and elevation are equal to each other. So if you say that was, say, 20 degrees, you're saying that this is also 20 degrees if you're going from the boat up. So another common little one, you've got your cat and it's looking up at the bird in the tree. Yeah? So they're looking up. His angle of depression is equal to the cat's angle of elevation. Okay? So you might use that instead. So say down here in this boat sort of incident, you might, because you've been told the angle of depression is 20, well, we might use it down here because they might say, how high is the cliff? So we'll use that right angle triangle and use that fact. All right, so we've got a little example over here. From the top of a 3.2 mountain, so I'm just going to do like that, 3.2 kilometre mountain. A car is 6 kilometres away. They're a little bit vague on this, so I'm just going to say that's 6 kilometres. Okay, what is the angle of depression from the mountain to the car? So remember I said join the two objects up. The angle of depression will be measured from the horizontal, so they want to know that. But can you see, I know that's the same as that angle there. So in the end, I've got a little right angle triangle. So once you've sort of got your scenario out with your little diagram, you might just simplify it and go, right, this is what I've got. Got 6 kilometres and I'm looking for that. So you label up your triangle like you used to. So I've got opposite and I've got adjacent and I'm using a right angle. So which one would I use? Tan, good. So tan angle, I'm going to write out my rule, 3.2 over 6. So remember when we're finding the angle, we can just use inverse over 6 and we're going to find out what that is. All right, so I've done that one. And they're always generally the nearest degree with degree things. So it was 28 degrees. Okay, so now we're moving on to, they're going to talk about bearings and things. So the first set of type of bearings is we can have cardinal directions. So that's pretty much just talking about north, south, east, west. So things that you might want to remember, if they say you're walking, if they said you were going due east, so what's happened is you've started, and it means you're going out that way, like straight along the east line. So you got to remember things like between north and east, how many degrees would that be? What's that? That's a right angle. So what's that? 90. If you were going from north down to south, 180, good. And say you were going from north round to west, 270. So you can see things like that. All right. So, but mainly they're going to be using is compass bearings and true bearings. So with the compass bearing, they're always going to begin with either your north or your south. So see here, they're saying your north. So it means we start here. Then it's going to tell you how far you're going to move away from north and in what direction. Now, because it said east, I've gone 30 degrees towards east. So 30 degrees is that angle in there. So if I said north, 30 degrees west, what you will see is that you're going to start at north and head towards, this would be 30 degrees in there, okay? So, and you've headed towards the west. So sometimes when you know that, see how, because we know that's 30, I actually know what this little angle in here is. What's this angle? Because they've got to add up to 90, good, that's 60. Same here. So you can see little things like that. So if I did another example, if I did south 20 degrees west, what you've done is you have now started at south and you've gone 20 degrees towards the west, okay? So you either start at north or start at south and swing each way, okay? Now, so that's what they are. Now, if we were looking at true bearings is always starting at north, okay? So you start at north for true bearings. So always start here. And then what you do is you go how far you're going and you say how many degrees. So it's going to be between 0 and 360, isn't it? Because you've gone somewhere between a full circle. So if you look here, say if I was going to do the true bearing up here, I'm doing true bearing in the purple, I would have started at north and I'm going to go all the way around to there is 180 plus another 20. So what would that be? 200 degrees true, okay? So that's where you are, all right? If I did this one, I've started north, I've gone all the way around, and I'm 30 degrees short of a full circle, which would be 330. Can you see that? Because I know 360 minus 30, yes? And then notice with this one, or down here, we'll look on their example, see how when they've only gone 65 degrees, they've put a 0. So true bearings always have 3 digits, okay? So if I had another example, if I had a line out here and I said that was 20 in there, the true bearing will be 020 degrees true, okay? So it has to be a 3-digit number. All right, so we're going to use these in setting up some questions. So let's go over and have a look at them. Okay, so a road from town A runs due west for 14 kilometres to town B, and a television mast is located due south of B at a distance of 23 kilometres. So draw a diagram. So what I want you to do now, you can see here, I've started, you're always going to draw one and you're going to start and say that's A. So can you see I've started A? So now what I want you to always do is do this, seeing how in grey I've drawn a light compass. So in your pencil, you're going to draw those little, it's a light compass. So what I want to see is a north, south, east, west line. So I'm just going to take that off. I don't want the pink there. But you see how I've drawn it in grey? That's what I want you to do lightly in your pencil. So you've got your start point, and then when they say a town runs due west for 14 kilometres to B. So I'm going to draw a line. Isn't that on the west line? Until I got to B, and then I've drawn my little compass on B. Now, I do that too, and I'm linking A and B together because they're on the same west line, aren't they? Yeah? So they're exactly parallel there. So we do B, and they said 14 kilometres, so I'll put 14 kilometres. Then you're going to go somewhere else from B, because then they said a television mast is located due south of B for 23 kilometres. So I've gone down to 23 kilometres due south. So that means exactly on the south line to the TV mast, whatever that is. Okay? So, and they said that was 23 kilometres. Now, what I want you to take note of, can you see that my 14 kilometres line is shorter than my 23 kilometre line? Yes? You should make sure that you're roughly in scale, okay? Not like to the thing, but if you drew your 14 kilometre line like that and then your 23 kilometre line like that, it will stuff up your perception of what's going on, okay? So try as much as possible to be realistic, and then you will find you won't have as much confusing diagrams in front of you. Okay, so I've used my ruler, so really handy to have a ruler so that you're roughly doing it correctly. It'll make your life so much easier. All right, so I've drawn the diagram. I've got that now. Now it says find the bearing of the mass from the center of the town. So the town was A. So when you see this word, the wording from the center of town, that means where you've got to start from. So that means we're starting at the town, which I believe was A. Yeah? Okay. So what you want to do is you want to link up the two things that you need to find the bearing of. So wasn't that at the TV and that thing? Yeah? So I'm going to link them up. So there's the line, drawing them. And what they're asking me is to go from A's north, and you keep going around until you hit the line that's joining them together. Yeah? That will be the bearing of the mass from, which means I start from A. Okay? So if you look here, do we not have a right angle triangle there? Yeah? And we could, if I looked here, if I went from here all the way around to there, would that be 270? Yeah? What happened if I took away this angle? If I said 270 minus that green one, would that not equal this pink angle? Oh, sorry, I'm better, not pink angle. I might just say this, oh no, it would. It'd equal the pink one. Yeah? The pink angle. I'll just do that line. Would you agree with that? Yeah? Or you could do 180 plus whatever. But let's go find that. Now, if you think about it, I have this, if I simplify my triangle, I have a right angle triangle here where I'm trying to find this angle here. So I'm just going to say I have opposite and I have adjacent. So what formula will I use? So tan theta equals opposite 23 over 14. And I'm going to find that by doing inverse. And I end up the angle equals, what does that equal? 58. So maybe I'm going to round to 59 because we generally always talk in whole degrees. So 59. So, therefore, my answer is going to be 270 minus, now I said this was 59, so 59, and it's going to equal, so what will that be? 211 degrees. So the bearing is, we're going to say 211 degrees true. Alright, a yacht from point A sails on a bearing of 38 degrees for 3,000 meters. So can you see I have started here and I've drawn point A down here. Now I'm going to go off, I've drawn my little compass and it's going off at 38 degrees for 3,000 meters. So I've gone, I know 38's roughly around there, you know, it's not quite 45, a bit less than the halfway between the 90 degrees. Now, I know that's 3,000 meters. And then I got to point, it then alters its course on a bearing. So it got to this point. Now, they're talking about A and B. So I'm just going to call that point C anyway. They got to there. Now, from here, that's when they're saying they alter their course. So can you see here, when they say it then goes on a bearing of 318, we're going to go from here, this guy's north, go all the way around to 318. Wouldn't that be up here somewhere, past the 270 mark? So can you see that's what I'm doing? And then I've got it ready. So then I've done that. Oh, sorry. And I'm drawing, linking them together. All right. Oh, sorry. That little north. If we might start adding a few pieces of information now. Now you told me that around from here to here was 318. Now if I told you, you know if I go from the north round to there, it's what? 270, isn't it? So what would that make that little bit in between? Wouldn't it be 318 minus 270? Which would be 48. Are you happy for me to say that little bit in here is 48? Yeah? I have said 318 minus 270, which is the, let me show you. So that was the purple line. That's the pink line. That would give me 48, wouldn't it? Am I saying the wrong number? Is that right? No, I'm saying 42.
42 is on the other side.
So 318 minus 270 is what?
48.
Yeah, 48. Okay, so we've got 48 degrees is that little bit in there. Okay, now someone else is saying, well, if you go, if to here is, yeah, so we know that's 48. All right. Now, you also knew that this was 38 degrees in here, wasn't it? Yeah? Sorry, I better make that, I'll make that a little bit bigger. So, up here, they said the bearing was 38. So, I said that's 38. Are you all happy with that? Mm-hmm. Yeah? Remember, if you have two parallel lines and then you have a line in between, doesn't that angle equal that angle? Yeah? So I know, therefore, up here must be 38 too. This bit in here. Yeah? And what would add up to 90? 38 plus what will give 90? Because there's a right angle in here. 52? So you're going to say there. So we've got that's 52 degrees. So can you see now, I have the whole angle of that bit in there, which is 48 plus 52, which is 100. Okay. So when they say, first of all, they're saying find the distance. So we got to B, and then it says find the distance of AB. So our first question here is find AB. So what I've got to do is join these two lines up. So I'm going to join those two. Oh God, I can't get the ruler. So I've joined those two up like that. Sorry, it's a bit off. Now, we also knew that this was, sorry, I didn't write, this was 3,300, sorry. All right, so we've now got that. They want me to find AB. So this is essentially the question. This is AB, okay? It's a bit messy now. I want to simplify what I've got. So I'm going to quickly redraw my diagram up here, and I've got a triangle like that. I'm a bit off, but I don't care. I've got 3,000. This is 3,300. I know this is 100, and I'm looking for this. And if I call this A, I'm going to call that C and that one B. If you look, I'm actually trying to find little c, aren't I? Yeah? And if you look at your formulas, you'll be using the cosine rule. So you'd say c squared equals a squared plus b squared minus 2ab cos... Sorry, that's the rule was there. 2ab cos c. Okay, substitute your values in. So for me, I called it x, and a is 3,300 squared plus 300... whatever. Oh, I'm going to run out of room. Blah, 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 blah. Yeah? And then you do solve, comma, x. Yeah? So C is 100 degrees. So let's go do... So I've worked that out. So we've got x to equal 482... Oh, I'm going to round it up. Did it say nearest meter? So 4830. Okay, meters. So AB, there's your answer for that. Sorry.
Couldn't you just use pi tag?
You could, no, because you don't know. It's not a right angle triangle. So you can't use pi tag. So you can only use them if it's a right angle triangle. So this one wasn't. So there's the answer for that. Okay, so now they're saying find the bearing of B from A. So that means I have to start at A's north and go all the way around until I hit the line that joins them. Alright, so can you see if there's the north line, it's just a little bit shy of going all the way around 360, isn't it? Now that's very hard. That's just luckily because I've done a diagram that has come in like that. But can you see if we find out, we know from the north line to there is 38. If I find out this whole angle here, okay, so what I'm looking at is I'm trying to find this little bit in there, okay, so which is like a little part of that. And if I find out this whole angle, so the whole angle of the triangle, I think I better change that colour. Wait a minute. If I find out this whole angle here, that means I'm finding this whole one, like that. Can you see, I could say that angle minus the 38 will give me that little green angle, which is going to be how I can work out the bearing, because the bearing is going to be nearly a 360, isn't it? Yeah, minus that. So let's have a look at if we can find. So if we're trying to find up here, so now we're trying to find this angle here, so up in our original triangle. So I'm going to use the sine rule because I've got two sides and two angles I can use. So where I'm going to go is I'm going to say I want angle A, so I'm going to say side A over sine A, because that's what I want, equals, and I'm going to use another one that I've got, which I'm going to use, we've found side C, so I'm going to use C over sine big C. Alright, so I'd plug in my answers, so that's 3,300 over sine X, that's what I want to know, equals C, which is, we just found, 4830 over sine 100. So you're going to put solve into your calculator here, and let's go find out what that angle is. Okay, so I've popped that into the calculator, and if you've done that too, I've done solve, and I've got a funny answer. I've got two solutions. So this means I have the ambiguous case. So I actually just want, looking at the angle, I want the smaller option, don't I? You can see in my diagram. So to save myself hassle, I'm now just going to put an n in front of nsolve. Remember, that gives us the smaller one. And how would I find if I needed the other one? I'd do 180 minus it, wouldn't I? So if I do nsolve, I end up with that angle being 42 degrees. Okay? So now, what I said over here, which is actually, this is actually the red angle that I found up in that triangle. So I now know that this is 42 minus 38 will equal what? 4 degrees? Yeah? So this little angle in here between the north line is 4 degrees. So what's the bearing of B from A? So therefore the bearing of B is 360 minus 4 degrees, which is 356 degrees true. So there's your answer.
Miss, what are the 30 degrees?
So, two hikers, Anton and Beth, walk in different directions from a camp. Beth walks 12 kilometers on a bearing of 135. So can you see, I put Beth out here, so I've got the C for campsite. Okay, so I've done the key for the campsite. So what you're essentially saying is that around here to here is 135 degrees. So if you know that, you know a few other things. You know that from here to here, isn't that 90? So then does that make this one to this one 45 degrees? Yes? So you know a few things like that. All right, so they then said Anton walks, and you know that's 12 kilometers. Then they said Anton walks 6 kilometers on a bearing of 45. So out they go, out Anton goes for 6 kilometers. And they said that that's 45 in there. So in here is 45, but doesn't that make that little bit in there also 45? So can you see now, you've worked out in total, you've got this 45 and this 45. So what's this whole angle bit in between those two lines? 45 plus 45, which is 90. So you've actually got a right angle triangle now if you needed it. So on what bearing, let's look at the question. On what bearing to the nearest degree should Anton walk from the lookout tower to meet Beth? So from Anton is what we're trying to find. So we're going to start at Anton. So we're going to join the two people we're talking about together with a line. So there's the line. And if I was talking about the bearing, I'm starting at Anton and I want to go all the way around there. Okay? Now, so what I need to know is, wouldn't I need to get this, I need to know what this little bit in there is. Would you agree? Because wouldn't the answer is going to equal 180 minus that dot. Would you be happy with that? Yeah, that little dot in there, in between the south line and that thing. So if you look, what triangle have I got? I've got this triangle. And so I know that's a right angle, and I know this is 6 kilometers and that's 12 kilometers. You also knew if sorry, they told you that this was 45. Doesn't it make that bit 45 as well? Yeah? So in there, I'm going to rub out a little bit. Alright, so we've got this recording, so that's okay. So we said that in there was 45 as well. So can you see, if I get this, sorry, I'm going to change the colour for you. If I get this angle here, which is this one, yeah, can I say that angle minus 45, would you agree, equals the dot, the little dot I need? Is that true? Yeah? See the dot over here? The 45 plus that dot gives the purple one. Yeah? So I'm going to go find this purple angle over here. So, and I'm going to use whatever. So I've got opposite, I've got adjacent. What would I use? Tan. It's a right angle triangle, so I can use tan. So it equals the inverse of tan. So the angle is 63 degrees. So you just told me what that purple one is. So 63 minus the 45 equaled the red dot, which means it is, what's that, 18? Is that right? Yeah? So 18 degrees. So if you know that's 18 degrees, you know the answer now for is 180 minus 18 degrees, which is 162 degrees true. Alright, so with this one, so someone just asked before, are those little compass lines going to be on the question? No. That's what you've got to draw up every time. I've done it to help make this process a little bit quicker for us. But you need to do that. You need to get those, you're going to get just that black diagram there. I've gone and put the compass things on it to help me see things. So it says the diagram above shows the route of the cross-country race. Point X lies due west of point Z. So when they say point X lies due west of point Z, can you see, we know that that line's going exactly along there. Well, X is east and Z's west line, okay? So you know that's exactly. So why did they tell you that? Maybe so you know that's a right angle triangle, you know that's a right angle triangle and stuff like that. All right. The bearing of point Y, now here's the question. So the bearing of point Y from X. So from X means I start at X and I need to go to the line that joins X and Y. So I've done that. All right. You know this is 115 and you know this is 27. So this one would have to equal 180 minus those two. Would you agree? Because they've all got to add up to 180. So what do we get that to be? All right, so you know this is 38 degrees. I just told you that was a right angle triangle. So if that's 38, what does this become in here? Because that's 90. So 38 plus what will give 90? 52. Good. So isn't that the line that we want? If I'm going from the bearing of X to the bearing of Y, so how do I say that in maybe true bearings? So the answer, you go from the north line till you hit it, so it'd be 0, 52 degrees true. Or if you wanted north, 52 degrees east, same thing. Okay? That one was the easy one. Points M and P are the same distance from a third point O. So what you would be doing originally is setting up this one first. Do point O. So you do your point O because they're both going from point O. You draw your little compass line and then you go. Then it says the bearing of M from O. So that means we're starting from O's line and you go towards 38 degrees. So when we join these two lines up, okay, you just got told with this 38 degrees, that's in there. Okay, that's 38 degrees. Okay, then they said point P is 152 from O. So 152, so you can see it wouldn't be quite 180 and it would be more than 90. That's why I've headed out that way. Okay, so I know that that is 152 degrees. All right, sorry, I should have done that in black. Okay? I draw the dot and then I put a little compass on it, and then I draw the next dot and put a little compass on it, and so on. Now, what you had to remember, take note, they said that M and P are the same distance away. So what really they've told me there, that this is an isosceles triangle. Yeah? Same distance, two side lengths. Now, you can get this angle in here, can't we? What's that?
180.
No.
152.
Good. 152 minus 38, which is? What's that?
114. Is it 114?
Yep. 114 degrees. All right. Then now, let's go to the question. They've said the bearing of P from M. So I need to join P and M up. So I'm going to join them up. Yeah, I'm just doing that because you guys. Yep. So I'm joining P and M up, and what they want is the bearing from M to P. So that means I start at M's north line and go to like hit the line that joins P. Now you can faintly see the north line going down there like that. So once again, there's a tiny little angle in there after the 180, because wouldn't you get there to 180? Yeah?
182.
So don't you think the answer is going to be 180 plus that little blue dot? Would that be true? Yeah? Now, you told me that from here to here was 38. Now you've got parallel lines, so from here to here is 38. So if I know what this little red one in that triangle is, so that I mean here to here, wouldn't the answer be 38 minus that red one would equal my little blue dot? Are you happy with that? Yeah? Now, if I just quickly draw out my isosceles triangle, so I'm just changing it up. There's O, M, and P, and I've got a red line across there. You told me this is 114. If you have an isosceles, aren't these angles the same? So what would that be?
It'd be a half of 66.
Which is? 33. So you now told me that these were the red ones. 33. So that's 33. So what's the little blue dot equal?
5.
So what's the true bearing?
185.
5 degrees true. Okay? A large triangular park is set up in the city of Redhorn. The three corner points of this triangular park are A, B, C. And as such that B is 2.5 kilometres directly south of A. So I've gone off and drawn A over here. That's where I would have begun. And then I draw the little compass on A. And then I went straight down the line to B. And they've said that was 2.5 kilometres. They then said, and C is 2 kilometres on a bearing of 300 degrees from B. So when you're seeing that, the 300 degrees from B, means I start at B's north line and keep going around. Now, I go past the 270, don't I? I'm roughly past there, and I go, it would be out there, yeah? And then I've got C. So I've drawn my line. So I know that the blue line is 300. So I start adding things in, like I know that is 60, don't I? Because if I went all the way around a full circle, I'll know that's 360. So I've got things like that. They also told me the distance, I think, didn't they? That was 2 kilometers. So I've got that in there. Now it says draw a diagram to show the scenario. So really, it said a triangular park, so I'll probably just join those two up, okay? And that's fine. Now, when it says, what is the size of angle, the acute angle, what does acute mean?
Small.
Yeah, less than 90. Yeah? So what's the size of the acute angle ABC? When they say that, they merely mean the one at B, which I already put down in my diagram when I was working things out. So that's good for me. I've already got that answer. Okay? So what's the size? You can just say angle ABC equals 60 degrees. What is the area of the park to 2 decimal places? So what you've looked at, you have 2 sides and an included angle. You're going to be using that area sine rule one, the one we said area will equal. Now I'm going to probably start labeling up my triangle here. So I'm going to call that little a, this would be little b, this would be little c. So I've got angle B. So when I use the rule, I'm going to use a half AC sine B. So that was one of your new area formulas. So you go a half times A, which was 2, times C, which is 2.5, times sine 60. Okay, so I find that to be 2, and it says to 2 decimal places, so 2.17. Now this was measured in kilometres, but this is area, so kilometres squared. Don't forget to write all that. Alright. Over the page is the next part of this question. So hold on a sec, so it says, what is the length AC and give to 2 decimal places? Okay, so we've got find the length of AC to 2 decimal places. So when they're finding AC, they mean for me this line here, which is little b. So I'm going to go off and use, I've got the two sides and one angle. I'm going to use the sine rule. So I'm going to use b squared equals a squared plus c squared minus 2ac cos b. And into the calculator, I'll have solve b squared equals 2 squared plus 2.5 squared minus 2 times 2.5 times cos 60, and I'll go comma b. And I'll get the answer. So answer, which is AC equals. So I got AC, now it's set to 2 decimal places, so 2.29 kilometres. So I'm having a look, the other two are around 2 kilometres. I think I'm pretty good. Like, it's not an unreasonable. If I came out with 20, I think I've done something wrong, yeah? I'm looking for those things as I'm doing it. That's how I pick up if I've stuffed it up. Because if I redo the same thing, I'll make the same mistake. So I'm constantly looking, is that a reasonable answer? Does that work? Now, the last one, and I'm sure they're your favourite at this stage. What is the true bearing of C from A? So you got to go from A all the way around to the line that joins C. Now, can you see that that is just, isn't it, from here to here is 180 and then plus this guy, yeah? So that would be 180 plus the circle, yeah? Would give the answer. So how am I going to find the circle? If I think about it, I've just got this triangle, simplifying it. Okay, I want this angle in here, so I'm going to use, and I've found this other side now, I've got 2.29, I'm going to use the sine rule. So I'm going to say little a over sine a equals, and I'll use another one I've got, which is b over sine b. Okay, so into the calculator you'd have solve, little a is 2, angle A is what I want to know. B is 2.29 sine 60, comma x. Let's see what x equals, which x is actually my little dot. Shush up, boys, wait a minute. I've popped that into the calculator and I've got the weird answer, so I now know it's an ambiguous case. So it's an ambiguous case. I've got two answers happening. So I'm going to once again change to n solve, and it's going to give me the smaller answer. But can you see up there, is it the smaller answer? Yes. Is that an acute? Yes. You can see that it's a smaller answer. So we'll go and do that, and we get, I'm just popping that in. We get that it's 49 degrees. Okay, so we know this is 49 degrees. So that is 49 degrees. So what is the answer? 180 plus the 49, which would equal 229 degrees true. That's the true bearing, and that's the answer there. Okay, so Aliyah is bushwalking. She walks 5.4 kilometers from a starting point on a bearing of 45. So once I see the starting point on my page, so in blue now, I'm going to do it like if it was a blank page there. So in blue, I would start off with, what's going on? So in blue, all right, they told me she's got a starting point, so I do my starting point. Then what I do is, I know I've got a starting point, so very lightly I put a compass on my starting point, yeah? And I might just write that start, S for start. Okay, now she works on a bearing of 45 degrees for 5.4 kilometers. So what I do is I just get, and I'm going to just draw, I know 45 degrees is halfway. That's 90, so I'm going to go halfway between that, yeah? And off I go. I just draw another line. She goes out to another point, and I know that was 5.4 kilometers. And I straight away, so I don't get a hassle, I'm going to put that in there so I can see all the stuff, yeah? Now, I should probably go back and write that this was 45 degrees, so I don't forget. And I also know in here is also 45 degrees because of parallel lines. So I've done that just in case I need that. So she walks on a bearing until she reaches a hut. So I also might write that that's H for the hut. She walks 2.8 on a bearing of 300. So I'm thinking where 300 is, and I know I'm going from this north line. I go all the way, that would be 270. So it's somewhere out there, yeah? So I get that. I'm going to go somewhere out there. 2.8, I'm thinking it should be a smaller line than my 5.4. So I'm just going to do a littler line, yeah? And where does she walk? To a river. So, and I'm going to straight away put my little compass in on it, and then I'll write R for river. So what do I know? I know that because that was 300, up to there would be 270. So I know that this is 30 in there. I'm going to write that, yeah? And also I do know if this is 45, then this one in there must be 45, yeah? Because there's a right angle triangle in there.
And then the other one
and then,
60 minutes?
sorry?
Yeah, 60.
No, well, so now we know this in total, yeah? So let's just see the total distance she walks, and we also knew that that was 2.8, yeah? So what I need, what I need to do is I need to find the total distance. So she's going to walk back. She walks back here. So I need this x distance because I've got the other two. So off I go. If I simplify my triangle, which I often do, so I'll just go like that. 5.4, 2.8, and you guys told me that this is 75 in total, yeah? And I want to know x. So I don't want to use SH and that because that's not what I use my rules for. So I'm just going to able mine ABC, and then I'll call that little a, little b, little c. So I want b in my answer. So I'm going to use b squared equals a squared plus c squared. So you've got to look up and work out which one you're going to use. And you'll know that it's this one. And then we're going to pop in what we don't. 2.8 squared. Oh my god. Yeah, you know what it is. So get that freaking thing out of there. So cos 75. And just do solve and comma x. So let's go. Alright, so I get x to be 5.4. So, boys, so I've worked out that that's 5.4. So the total distance would be 5.4 plus 5.4 because there's two of them plus 2.8. So what does that equal? I think 13.6. So the course of a yacht race is triangular in shape and is marked by three buoys, T, U, and V. The starting buoy, T, and the yacht sail on a bearing of 30 degrees to buoy U, and then from buoy U it sails to buoy V, and the blah, 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 blah. All right, so they said the angle UTV is 69, and the angle and UVT is 47. So they've put all of that in the diagram. The only bit they don't have are those crosses, which I've put on. And the reason I've put them on there is because, have a look. If I know that that is 30 degrees, I know that in here is 30 degrees. Okay? Now, when they say the bearing of buoy U, so the question here, buoy U from V. So I'm going to go from V to buoy U. So it means I've got to go all the way around to there. Okay? So if you look at it, if I know what this angle here is, isn't that the same as this one here? Yes? And wouldn't the bearing, this red line, wouldn't that be 360 minus that purple circle? Isn't that what that line is? Yeah? So, because 360 would be all around. So, I need to work out this purple circle. How can I do that? Well, I know if I find this angle here, I'll just call it a star. If I do star minus 30 degrees, because that's part of it, would that not equal that circle? Yes? So I'm going to find that star. So now they're confusing. Well, I can work out the star by, if I quickly, I'm just going to quickly draw this triangle for you. We just got like that. They told me this was 69 degrees. This is 47. And what I'm saying is that this angle here is the star. Well, isn't the star, shouldn't it all add up to 180? So then we're going to say 180 minus 69 plus 47. So what does the star equal? What's that? 180 minus 69 plus 57. What is it? 54. So I got this to be 54 degrees. So 54 minus 30 equals 24. So 360 minus 24 equals 336. Maybe even 26. Yeah? So there's our answer, E. Alright, there's that one. I'm going to keep going. This is 64. So then that's minus... That's 64. That makes more sense. 34. 34. Which means 326 degrees. Really? This one, the answer's there. I'm just going to quickly say triangulation is what we've been doing. When they talk about a practical application like the triangular park, it's called triangulation. And this one, I'll pop in the answers for it before I save it, and you guys are finished. The last one here, the ambiguous case, I said we couldn't do it before. I said we'll do it once we've done bearings. There's a separate video for that, and I'll post it as well onto your thing. I won't do it in this one.
Could you go back to